In today's video, I'm going to teach you how to average wind directions in Excel. Averaging wind direction isn't the same as averaging temperatures or sales figures. Wind is circular data. 0 degrees and 360 degrees point the same way. If you just use the average function on values like 350, 10, and 20, you can get a completely misleading result because the arithmetic mean doesn't understand that wraparound. The reliable approach is vector averaging, which treats each direction as a point on the unit circle, averages the x and y components, and then converts that average back to a direction. Start by opening Microsoft Excel and putting your wind directions in degrees in a single column. For example, place your values in cells A2 through A4. Use your own data if you have more rows. The exact range doesn't matter as long as you stay consistent. Next, convert those degrees to radians, which is what Excel's trigonometric functions expect. In cell B2, type equal radians, A2, and fill the formula down to cover all your rows. You should now have a radians version of each direction. Now extract the components of each direction. In cell C2, enter QOS B2 to get the x component, and in cell D2, enter sin B2 to get the y component. Fill both formulas down the column so every direction has a cosine and c sign. These values represent unit vectors pointing where each wind direction is aimed. With the components ready, average them separately. For the x components, use a formula like average C2, C4. For the y components, use C average D2, D4. If your data extends beyond row 4, just change the ranges to match your last row. What you've created are the mean x and mean y for the set of directions. Finally, convert those average components back into a single wind direction in degrees. Use this formula in any empty cell. Equal to MODC degrees. Atan 2, average D2, D4, average C2, C4 to 160. Atan2 reconstructs the angle from the two components and correctly identifies the quadrant. Degrees switches the result from radians back to degrees, and MODI wraps any negative angle into the standard 0 to 360 range. You should now see the true circular average of your wind directions. This method correctly handles wraparound cases, like 350 degrees and 10 degrees sitting near north, rather than averaging to 180. If your result looks close to 0, remember that 0 and 360 are the same direction. Also make sure your inputs are numbers, not text, and that you fill formulas down to the last row of your data. That's all there is to it. If the video has been helpful and want more tips, please subscribe to the channel. It's free.